Mm.
But that principle in itself gives you an idea of what's going to create the greatest transfer. And I get asked this question a lot of, how do you design your programs? How do you design the actual structure of your training sessions or your training weeks? And it's all about understanding what is the most important factor that's going to make the biggest change for what that person needs.
At that point in time. Based on their training history. And I think part of that comes to a concept we'll often talk about of maturation.
Yep.
Because, I know we've talked about this a lot, and it'd probably be useful to explore it, say, with looking at some of the track athletes you work at. Their training age is going to give you indications about, one, the magnitude of stresses that they can tolerate, and two, the actual response to the stressor.
All right, so let's wind it back. What give a basic definition for people of magnitude?
Okay, well, magnitude the main factors that will influence magnitude is the intensity of the stimulus.
So if that was running, it would be, say, the speed that you're running at?
Correct. And I think the two main variables we think about when we think about mechanical stressor and intensity is the force characteristics and the velocity characteristics. And so, a good example to think of is for the untrained athlete, or for someone maybe even in the general population, or someone following an injury, their stress tolerance is going to be a lot lower. So the magnitude of the force or velocity that they can tolerate or positively adapt to is going to be much more at the lower
and
range.
I think we understand this inherently. If you ask someone about, say, resistance training, and you said, all right, every day you're going to go and do a 1 RM, you would realize pretty quickly that that's a recipe for disaster at a certain point.
Yes.
Because the mechanical tension that you're creating day in, day out is not able to be withstood by that individual because they haven't done a lot of resistance training.
Yes.
Right? So their tissue probably isn't going to tolerate it. And if we divert very briefly, I won't go on too much, but if we look at a mechanical model, and as we've said, the human body is not a mechanical model, but to give us some understanding using an analogy, if we want to say, if you look at stress life curves, which are used in materials engineering, basically what they do is they take maybe, say, a piece of steel, and they'll apply a mechanical tension to where they're bending it, and they'll see how much force can they put through that piece of steel and how many times does it take before it breaks at that level of force. And they'll do it at a range of different levels of force application to that piece of steel. It's a silly example, but I'm sure it's been done before. And what they find is the curve shows that if the magnitude's really high, it needs very few cycles of stress, and if the magnitude's low, it can tolerate much more cycles of stress, right, before it breaks. And we can apply this in a very simple sense to the human body. It's not, as we said, it's not a perfect analogy because the human body does have adaptive abilities, and it's much more complex than a basic mechanical model.
And it's actually not linear too, because if you look at the
stress life curve is not linear either.
Yeah, okay. But I was thinking, you see that too with, like, say, the stress-strain relationship, where it actually is exponential.
Yeah.
And it's based on not just the magnitude of force, but also the rate of loading too.
And we understand this, right? I gave this example in a blog that I did. I don't remember exactly which one, so apologies for those listening, but you will be able to find it in one of the blogs that I wrote, where everyone understands magnitude in the sense of failure for a tissue or a whole system. When you say, okay, if I asked you to jump off a 20-story building, you know that's going to be catastrophic failure, right? And say 20 stories, I don't even know how tall that is, but say that's 100 meters, right? But if I ask you to jump off half a meter 200 times, you could probably do it without your tissue failing, even though the cumulative height that you've fallen from is 100 meters.
Yeah.
So the magnitude of that is way too high for what your tissue can tolerate. And the same thing happens with training. If I said to you, all right, Jack, load up the bar over there and you're going to try and do a 200 kilo bench press, you probably would hurt yourself if we unloaded the bar.
I think that's unfair.
You'd probably hurt yourself,
yeah.
Right? But if I said to you, I want you to lift 50 kilos 4 times,
Yeah.
you could probably do it very easily. So it gives us the idea that the repeated cycles are tolerated better than the actual magnitude.
Yeah.
And we have to think about this in terms of stress tolerance, because this is exactly what we're trying to develop in an individual when they have no stress tolerance. That's why, for instance, if you look at programming and you look at periodization models, and for those people who haven't heard the term periodization, it's basically organizing how you apply stresses or training stimulus or rehabilitation sessions or stimuli or exercises. Typically, people will start with a stimulus that requires more volume but is at a lower intensity. And it's for this very reason. They know that implicitly that individual cannot tolerate the same level of mechanical stress and or metabolic stress.